Hello, everyone, and welcome to the Cleveland C Sharp User Group. A little bit about the group. We meet every month. The meetings are free of charge and open to the public, and we cover a variety of topics related to .NET. You can find meeting information for both past meetings as well as future meetings at the link listed at the bottom of the slide on meetup.com. We would like to give a big thank you to our sponsors, PostSharp and DevExpress, for sponsoring the post-meeting prizes, which will be given away using the eval forms. I would also like to thank the .NET Foundation for sponsoring the Meetup site. And last but not least, NIS Technologies for sponsoring the virtual meeting space. In addition, I'd like to thank Manning.com for a special offer, 35% off a selection of books with the discount code MTPCLEC21. And those books are listed at the link listed at the bottom of the slide. The discount code as well as the link will be posted in chat shortly after the meeting. Some general information. First and foremost, please keep in mind participation is encouraged. And like I always say, the only stupid question is the one not being asked. So feel free to jump in with any questions or comments. However, when not speaking, kindly ask you to mute your microphones just to avoid any background noise. And we want to keep it casual but organized. So the presenter will stop and take questions as they come. But at the same time, we want to give But at the same time, we want to give our presenter enough time to go through all the slides and the demos. Lastly, the meeting is being recorded and will be posted on YouTube after the editing process. So for tonight's feature presentation, we have Sean Whitesell, and he'll be presenting on data patterns for successful applications. Sean is a senior cloud architect for ArchitectNow. He has over 20 years of programming experience. He's also a Microsoft MVP and an ASP insider, and he runs the Tulsa.NET user group. And if that's not enough, he also has multiple black belts in martial arts. So with that, I'd like to welcome Sean.
Yeah, thanks for having me as well. I appreciate this.
Oh, thanks for being here.
All right, so tonight we're going to talk about data patterns for successful applications. This is kind of a collection of some data patterns that are kind of widely known, along with a lot of my own opinions on some things. And we'll cover some other topics that are not necessarily data patterns, but there are things that I think that you should know about along with the patterns. So as we go through this, like I said, holler if you got any questions and be happy to address them. And there's probably going to be plenty of time at the end if you want to go through some scenario-based questions, we can do that as well. So to get started, we're going to start with the idea of, well, the common architecture. And this is what the standard architecture most everybody's already familiar with. You got an application that's talking to a data store. And as things grow, you have another application, not another instance, but a different application altogether that's also talking to that same data store, and more specifically, the same data. And of course, as things happen, things grow. So now we're into multiple applications, several applications hitting that same data store. And of course, as things happen, not only do you have growing code base, but you have a growing schema, a growing set of data tables, or however the data is stored. So generally what we have is in this kind of architecture is we're going to have some sort of a code base. We generally call it the data access layer. And it could be inside your app. Maybe it's in a DLL package of some sort and it's shared across the applications, however you want to do it. But inside there is where we're going to take our first peek at some things. And generally, when we're looking at some code, we're seeing things like create an insurance claim or get an insurance claim info by ID. Some kind of rather common type of methods to deal with getting and retrieving, creating data, etc. Now, hopefully, you've already doing this where you've got not just the create insurance and the gets, something simple, but you've got maybe even kind of expand this out a little bit better so you have more specific and a better domain language of things like pay insurance claim, approve insurance claim, reject, etc. And one of the key pieces about this is that they're all using the same class, the same type. And you can tell I'm trying to be very generic on my example here, because although it could be .NET, could be Java, it could be something else. I'm not trying to get into that piece per se, but just trying to represent objects as they are, moreover than anything else. So as we're dealing with this, we've got a separation with our methods for pay, approve, reject, but they're all still relying on the same type, that claim info type. And the problem here is that it has properties for everything about a claim. Well, that's fine, except that there's some inherent problems with this, and we'll discuss that here in just a moment. But something I want to point out is the details about those methods that are using this common class. There are things that change state, and there are methods that retrieve state. All right, that makes sense. We're gonna, like I said, pay an insurance claim. We're going to approve it. We're going to reject it. Things that are going to change the state, and however that's persisted both in memory and to a data store. Well, and then you've got the other type of methods that retrieve that. And this first pattern is called the command query separation, CQS. You've probably heard of CQRS, and you're thinking this is similar. Well, CQRS is built on top of CQS. So this is why we're starting here. And the whole point of this is that you want to have a big separation of the commands that change state versus those that retrieve it. And the
Sean,
point being, yes.
can I interrupt you? Sorry, we lost you there for a little bit. So shortly after you said there are methods that change state and others that simply read it, and then your audio just dropped out for a bit.
Oh, okay. Sorry about that. That's
No
interesting.
problem.
Okay. All right. So yeah, we've got the methods that change state, such as the pay, approve, reject insurance claims versus the retrieve state. And this is that common query separation pattern. This is our first pattern. If you've heard of CQRS, CQRS is actually built on top of CQS. So this is why we're starting here. The main point of CQS, that command query separation, is that the retrieving of data should not cause data to be changed. The very act of pulling data, retrieving data, should not change any data and however it's persisted. So now let's go forward just a little bit and think, well, I'm actually already doing that, which is fantastic that you are. So just know that I've come across this when I've mentioned this to others, like, well, I'm already doing that. It's like, this is the name of the pattern that you're actually doing. A lot of people don't realize that that's a pattern. So going back to the common architecture where we have multiple applications pointing to the same data store, and we have shared code between the applications, and we have a shared schema between those applications. One of the problems with doing this is that you're going to have a list of pain points, and that's what we're going to discuss right here. When you're sharing code between applications, you're going to have code change contention, meaning that just because how one application handles code and the model, another application may come in and try to make changes to that common data access layer, or maybe it's a NuGet package or whatever. And now there's changes that are fighting with each other. So you have a pain point to iron out. Another one is sometimes those code changes could cause performance differences. So you may be introducing something that's great, it's helpful for your application, but it turns out to be harming something else. You got to be very careful of that. The other part of that is when you have shared schema across those various applications, it's not really clear as to who has the ownership of those schemas. So when changes are to be done, who's to say who was right? So sometimes we're going to have to go against a principle that most of us have heard, and that's that don't repeat yourself. But there will be times when you're going to have to duplicate code to allow the applications to evolve independently. So if you do have some code contention, you're going to want to duplicate that code, because that duplicate code is not going to stay identical for very long, right? It's going to split that off and allows those applications to evolve independently. Another giant piece to this is that when we get into our schemas, we like to have, I apologize, I'm jumping ahead. So we may have a column, for example, that where one application is looking at a processing code and is treating it as a string, whereas another application is trying to use and treat it as an integer. Well, who's to say which one's right? The first one there is not always the right application, the right way of handling that data. It could have been a misunderstanding in a business requirement or in something about the industry or whatever. So there's times when we have to work out, identify those pain points and iron those out of how we're going to do that. Another piece of that is when we have an index built on top of, let's say, SQL Server, for example. And well, I've got my index, and then with somebody else's application, they're going to build their indexes, and then somebody else comes along and they're going to have their indexes. Well, that's not good enough. So now we have yet another index. And of course, that causes the problem where the indexes are constantly being rebuilt. And they're constantly working, and that can cause a lot of contention and performance degradation on that server, that database server. So you've got to be aware of that. Now, there are applications that, as we're working with the same data store, where some of the applications need to read and write data, where other applications, for example, may only need to write data. Things like any applications that are retrieving IoT data, telemetry type data, where it's not trying to read the data store, it's just trying to grab that data and shove that in as well as it can. That's fine, obviously, until you get locking contentions and things like that. And then comes along a giant application, a very heavy read application that we know and love as Power BI or others, right? There's plenty of other reporting solutions out there that are going to be very read intensive. So against that data store. So we have to be very careful in our architecture, because at some point that database is not going to be able to support all of the types of demands that it has on it. Now, before I dive into that part of there, I want to touch on one thing right quick. I keep saying data store, but not a database. Let me discuss what exactly do I mean by that. So a database is a data store, but a data store is not necessarily a database. And what I mean specifically about that is that a database has an engine, something that maintains the data integrity among the other functions that it provides. Whereas a data store could be a database, but it could also be something else that it doesn't necessarily have an inherent engine. Something that still has data available for processing, stored in a variety of different ways, but is, like I said, does not exactly have an engine that doesn't care necessarily about data integrity going across the different pieces. Okay. So that's kind of why I talk about data store versus database, because a lot of these patterns can go across various data stores. Sometimes they're specific to a database and database type, but some could be considered across a data store. Okay, right quick, as we're looking at this claim info data model, this data transfer object, if you want to call it a DTO, that's fine too. It could represent a table or a view in a data store or whatever, but it's essentially a data model. So The problem with this, and this is something that I would do as an architect, is I would look at this and go, is it really claim info, or can we call it more specifically claim info details? Because it has all the details. It has the everything in there. What if we were to also add another data model that has some of that information, but not all of it? Something like, if we're going to have a new claim info, we don't need to have all the payments, investigation details, et cetera, at the time that we're creating a new claim. Obviously, you can tell that this is going to be business process or business rule specific, but this is where this comes in. I have an object that is specific to the purpose. And I can even step this out even further and say, well, I've got an object for adding a claim payment or adding claim information documentation. Maybe I'm adding a claim investigation detail, whatever that is, but you can have those specific objects for those specific models for those purposes. And when you do that, you have what is called the write models. Well, all right, that makes sense. They are for when you're going to write data to a data store. Going the other direction, back to that claim info's details, right? Now we've got everything as far as every bit of a claim info, but now we have the other type of models that are for when we retrieve information. So it could be about applied payments, maybe it's about a resolution details, maybe all of the claim status history, however you want to define those out. Collectively, those are the read models. All right, that makes sense, right? So now with our application that works with write models that change data and read models that do not change data, going against a data store, this is the pattern CQRS. So leaning on CQS, where there is a separation of purpose for the commands that change state against the commands that retrieve state, that are not allowed to change any of the data when they retrieve. But this goes a step further. It says not just at the method level, but go to the actual models themselves, and then how they are designed and used is for the purpose of the CQRS pattern. So then our application has the read and write models specifically for that. Now, remember we were talking about this issue earlier, where I have an application that's trying to write data in a lot, like telemetry, things like that. But I also have this really read-intensive application, Power BI or some other type of application or reporting solution, whatever. And what I want to do is to separate my data. And what I mean by that is I want to pull the load apart so that I can support my applications, but I can also pull away the purposes individually. So I have my application that can write and read from a data store, but my heavy read application, such as Power BI, is reading from a replica. Now, this sounds great, but now I'm responsible for duplicating that data. I'm replicating that data to something else, another data store. Well, when should you do that? You should absolutely consider doing that when the performance is degraded so much on the first data store that it's really having trouble surviving. And I don't mean to wait until it gets to 100% CPU load, 100% at the time. It's going to be at some breaking point before that you're going to want to start replicating your data, because even the act of replicating data is going to take some CPU and processing power. Depending on the type of data store that you have, you can leverage the built-in replication capabilities. MySQL, Postgres, SQL Server, Mongo, Amazon Aurora, they have replication. Those are just a few anyway. They have replication built in. So if you're going to do a data replication scenario solution, leverage the replication capabilities that are built in. However, there will be times when you can't. And or you also want to go to a different type of data store. So what if we have our application that's trying to read and write from a primary data store, but we need to feed a secondary data store, but they have to be treated differently. On this slide, I'm showing that MySQL, Postgres, SQL Server, Mongo, Amazon Aurora, among others, when they replicate, that data is binary exact copies that is brought over to the replica, meaning that you cannot have a deviation of the type of data. What if that's something that you need to do? A possible solution. So I'm not saying this is the solution, I'm just simply making an idea, posing an idea, that something you can do is that have your application, when it's time to write data to a data store, you can have the message, use a message bus, and where one receiver, or consumer, is handling the data differently or however that needs to be handled. What if they're both relational data stores? Okay, great. Then the consumers are picking up the data, doing whatever data massaging they need to do, and then store that and is responsible for getting that data to those individual data stores. Now, like I mentioned, this also allows for the data to be different types, meaning that the replicated data down below on the bottom there could actually be something different. What if it is not just a relational database, but what if we need to feed a flat file of some sort, something in a just stored completely different? Maybe it's a table storage, or like I said, flat file, or something else. That's possible. When you do that, obviously you can go to an entirely different types of data stores in the actual different types of engines, relational with SQL Server, or Cosmos with a DocumentDB type. What's interesting about when you do this is that it is possible that if a data is being written and it's going to go to one data store, but it's also going to go to the other data store, that there's a possible time delay for when the data is replicated across, and as in being received in both data stores. So I'm headed towards what is not necessarily a pattern, but it's something I want you to be aware of. When you have replication of any kind, it's possible to have a delay in the data. Now, when do you actually care? Well, if you are comparing the data, let's just say that's one record, and you're quickly doing a read from SQL Server, and then you also do the exact time in a parallel process, you're doing a read for that data, let's say over in Cosmos, and you're trying to verify that the data got there in both places. And let's say that it's in one place but not the other. You wait 500 milliseconds, you read again, now it's in both places. Okay, great. That's when it's called consistent, is when that data is now committed across the one or more replicas or other data stores, however you want to call them or reference them. So what this is called is eventual consistency. So this is the first part where maybe I've got a microservices architecture. I'm trying to write data to multiple places, but it's getting to one data store, but there's a delay of it getting to another data store. It could be because I'm trying to write, let's say, because I do a lot with Azure, maybe I'm trying to write to a primary region of where my data is at, but I'm also trying to write data to a secondary region, and that's, say, halfway across the US, for example. There's always a chance of a delay. When the data is in sync, as in it's in both places, that's where it's now considered consistent. So something that you'll see is that, we got a record 1 comes in, it's in both places, and this is what's 99 plus whatever percentage is of the time, this is what's going to happen. Messages come in, 1, 2, 3, but now, for whatever reason, maybe a network hop, network glitch, whatever the case is, maybe it's just got more distance to travel, we have a small delay. Now, that's fine. If it's just milliseconds, it's not that big a deal. And the reason I say is because it really depends on who cares. Who cares to read from both data sources to verify it's actually there? The only reason you should care is when you want to verify that a data has actually gotten to a target place. That's it. In Cosmos, there are 5 consistency levels, whereas in SQL Server, there's 2. In Cosmos, they've got one is eventual consistency, on the other spectrum is strong consistency. So if you want 100% guarantee that when I write this data, it is in every single copy across every region selected, you can go to strong, but you'll definitely pay for latency problems in doing so. So anyway, just wanted to point that out as far as what is consistency and the idea of eventual consistency. Okay. Now, have you ever noticed that in SQL Server, when you do a read, just a nice little select star from blah table, whatever, that sometimes the data comes back in a somewhat random order. It's not always numerically by ID, but let's say that I need to always guarantee that it's going to come back in a governed order. Well, obviously, we say order by. That's fine. But I also want to control that by using a view. All right, cool. What if I want to control even further and say that that view is pulling from other tables, not just one, but it's pulling from others? Now I can use the data store, like a database, in this case, SQL Server or Oracle, whatever, and I can use a view to help pull from different data sources, such as other tables, and I can control what the data looks like to help support a heavy read application, such as Power BI or whatever, or other applications for that matter. So now that, being a pattern is a view, but the problem with this is that every time there's a read, the view executes the query. So it's executing that query over and over and over again for every time that there's a request coming in. This could be, at some point, an intensive process in itself. So now it's consuming too much CPU, too much RAM, too much time, whatever. So what we'll come to is the next pattern, which is the materialized view, which is a form of a cache. So now we've executed it, it stores the results of that view. And when the applications read from that again, it gets the same answer that's already stored. It doesn't have to execute the query. This is great, but it also has its problem. So that problem is the fact that at some point, the data can be considered stale and it has to be rebuilt. So this is going to be up to you to decide both, is it time and or a business process that says that now this view, this materialized view, is now considered stale and the data needs to be rebuilt, as in requeried and restored, cache invalidation, and then rebuilt. Now, how do you do that? Do you want to set that up on a timer? Or you could do something as interesting as having a piece of data that triggers, say, a function, and that will go and invalidate the view and cause it to be, basically flips a little flag, and so that the following request comes in and causes that query to execute and rebuild that materialized view. They're obviously going to take the first latency hit to rebuild it, and subsequent reads from there will not have that. So there are interesting ways of doing that. And so now the pro is it can store it in the form of a cache. The con is now that it's stored, at some point it's stale. You want to be very careful of that. Okay, now inside something like SQL Server, SQL Server has a built-in way of doing a materialized view. But what if I want to use something else, or somehow have the materialized view outside of the database? Well, now you definitely want to store that in a cache, and this is what's called cache aside. So now it's external to a database system. You could use something like Redis or Azure Redis, something to that effect, to store that materialized view, that result set, outside of that data store. Okay, zooming right along here, let's talk about indexes. Indexes, generally SQL Server, and I say that because a lot of us have already done SQL Server. I've done a little bit of Oracle as well, but I cut my teeth on SQL Server like so many other people as well. So I generally lean on relational data types first. So with indexes in a relational database system, SQL Server, Oracle, whatever, you can index on a primary key, and yes, of course, you can index on other fields. Okay, that's great for relational data. But what about the non-relational data? Well, yes, Cosmos, for example, Cosmos DB has indexing capabilities built in, but I'm also trying to be more on the data pattern side, not application or service specific. So what if this set of data is not stored in Cosmos? What if it's stored in something else? And it doesn't just say what if it doesn't have indexing or good indexing capabilities, or you want to do a custom solution. This is where I'm simply pointing out that there is a way of doing this. So what if, in our example, now that I've got JSON data stored, and I want to, and I'll say, for example, I've got hundreds of thousands of records in there, and I've just a huge amount, maybe even millions of records, whatever. And I took a guess on Keith Richards' date of birth. I really don't know. I'm not even sure if it's actually known. 1603 is probably a decent year. I'm not sure. We'll see. I don't know. So the idea is, what if I need to search for where the first name is Bob and something else, but I've got a lot to traverse, a lot of data to go through. And when you're searching through JSON documents, well, off the bat, it's really hard to do. It can be rather cumbersome. So one of the things you can do is store information about things on a different table or a different document, however you want to have this. What if I'm going to search? So this goes back to another key point too. Let's say that I understand my search patterns. This is a key piece. Let's say that I happen to know that all of my users search first by a first name. It doesn't matter if it's a legitimate use case. I'm just saying, what if? And I want to also find all the Bobs that also have a date of birth between a certain range. Well, the first thing I want to do is not traverse a million records, but I can go and grab a subset. So the first thing I'm going to do is say, all right, here's all the records, 2 and 3 in this quick example, that are first name Bob. Now I've got a subset of data that I can traverse, find the date of birth, and then compare that to that range to see if I'm finding what I want. So this is where you can use an index table pattern, okay? All right, switching gears. What about a really cool pattern that I actually really like called event sourcing? Event sourcing is really cool. It is really nice. It has its place. This is going to be a key piece to this. You're not likely to just run out and use this tonight. You might, but I wouldn't be surprised if you're like, you're going to wait till that special time when it's really makes sense to use that. All right, so what if, like a checkbook register, where we have some starting balance, and now what we're doing is recording the money that's come in, and we're recording the money that's going out, okay? And what you're doing is on the balance, we're tracking the result of the change, okay? Meaning something like this. What if on January 1st, I have a open account and I put in $5,000 in it? Okay, cool. A few days later, put in $100, and then I do a withdrawal for $50, maybe out of store, whatever, doesn't matter. And then on the 15th, oh man, I hit the jackpot at the casino, right? And now I got a quick $3,000 in. This is awesome. So what do? Well, as soon as we get a large sum of money like that, we go and spend it, and then we go spend it. Yeah. So now we have a balance, but we're not tracking the balance here. We're only tracking the changes. So what's the ending balance, and when? When do we care? Because that's a balance as of. And what I'm doing then is saying, well, if I'm going to get the balance, I'm going to start at the beginning and I'm going to replay the events. I'm going to replay the changes of that data to get to a final state. I'm not tracking the final state, only the changes. Now, let's look at it differently. How about I've got an e-commerce site and I have a shopping cart? And a key piece to this is that each event, again, it's event sourcing, each event is treated as an immutable record. You can never change it, you can never delete it, but you can only amend. So in this case, I have a shopping cart and I add an item to that shopping cart. I've got 100 count of K-Cup coffee, $25. Probably a good deal, or it's really terrible coffee, not sure. So then I said, well, I needed some coffee stirring straws. So grab 100 count for $5.49, all right? And when I look at my cart, I have an add item and I have an add item. And then the data coming back to me is a result of the data, the changes that have occurred in that cart. Now, I decided to remove an item, okay? I found a better deal. So I got rid of the item of the 100 count coffee stirring straws for $5.49. Now I can replay, get my shopping cart right. So I have an add item, remove. And then I find the better deal and I add that to my cart. It's 100 more for only $1 more. Okay, cool, better deal, right? Go view my cart, add, remove, add. So what I'm seeing is the result, the ending result of the replay of events, okay? Where else might you see this? You might see this in tracking temperature, talking about IoT devices. Maybe you're tracking your hydrometer in a plant or something to that effect. And something where maybe you got something like forecasted versus the actual. Why would you care? Well, because you can replay that type of data for maybe the purpose of analytics. Now, so far, I'm giving you this example in what's very, very simple types of data. And that's fine, right? I mean, a single number here, single number there, just a quick item in a shopping cart. Those are very simple types. So when should you really consider using event sourcing? Well, I, for one, believe that this definitely has its place. And let's say you got logistics where you're adding things in stock, you're removing things from stock, you're replenishing your stock, etc., right? Network performance, you're not capturing the end of something going on, you're capturing the changes. and you could replay what has actually occurred. Compliance. This is kind of like a built-in history. Healthcare. This is a big one. If you want to think of it this way, where if you have healthcare records, everything that's done to you should be an immutable record. Cannot be changed. It could be amended, but have the record of the change. Yes, maybe like in a bank account, I gave a deposit. This actually did happen to me. I went to the bank, I deposited an account, and it turns out they deposited to the wrong account. And when I went and talked to them about that, they went, "Oh, we see the mistake. It was a little fat fingering, little number mix up." They had a money go into their account, and then they had money pulled back out of their account. It wasn't removed, it was two records, it was amended. At what point do you erase history and replace it with a new starting balance? Ooh. Okay, I would say it really depends on your industry, because if it's something like healthcare that has compliance, you can't. You can never erase history and replace it. Now, there might be times when you have something that is, let's say that I've got, just to give you kind of a weird example here, what if I have an IoT device and it's running for a month, and it's got all this telemetry for a month, and I'm going to start over the next month, but I don't care at this point, I don't care about the first 2 weeks of the previous month. What if I have summation? What if I've now summarized some of that information and I'm carrying it forward? So now in that case, you're not necessarily erasing or replacing so much as you can shift. And maybe now this same device, it's writing telemetry information, but its beginning balance, if you would, is a different record in there, and you can choose to take all of the previous records, and maybe you don't necessarily erase them. Well, you could, but you could push them off to cold storage first. So maybe you do something like that. Maybe, again, depending on the industry that you're in, the type of data, maybe you have simply cold data. We have not had any updates to this, let's say a medical record. We have not had any information to additional information for this person in our system, and it's been over, say, 15 years, just to pick a number, 15 years. What if you summarize that? What if you just move it off and put it to cold storage? Possible, just depends on the compliance that you may need to adhere to. And I forgot too, I gave this talk at a conference, and somebody asked me a really good question back to the shopping cart. Let me go back to that right quick. Okay, I'll just leave it right here. The shopping cart is to the persons, to me, right? I'm customer C123, right? And he says, well, what if they've purchased their stuff and they're done? Do you continue adding and removing to the same cart? And that case, I said, no, that is a different record entirely. Even though it's for the same customer, you still have a shopping cart ID. And that ID is kind of like a session, if you will. And so it's to the same customer, but the shopping cart itself is different. So that's where, even though it's to the same person, I'm capturing different events for a different session, time, shopping cart, things like that. Okay. Now, there's a key piece about event sourcing, a very big key piece to this. And I mentioned about immutable records. Treat every entry as immutable. You cannot change it. You can amend it by adding a new record, but you can never delete. You can never change. Okay. But a bigger key piece to this is that replaying the events is the source of truth. And what you're not doing is storing a final result, meaning you don't store your check balance, your checking account balance or savings account balance, whatever. Now, granted, I know it's always there, you always see it, that kind of stuff. But in this case, I'm saying you don't store that as a one record, here's your balance, go forth. You want to always have the ability to see how that came to be. Let's look at a scenario. If I'm storing that balance as current state, you can do that. But what if I have a change log? That being the event sourcing, right? I'm storing all the changes to state in a change log. Here's the problem. Which one is the source of truth? Okay. What about the case now, because they're still two different areas? What if, and it's possible, that the current state has an update that didn't get to the change log? What if the change log has an entry that does not get to the current state? Now they're out of sync. Now, I think we'll just wrap that in a transaction or whatever, but they could still be in different systems. They could be entirely different types of data stores. So the point of event sourcing is having that data as that source of truth. It is like built-in history that you replay to get that final state. What about adding CQRS and event sourcing together? Absolutely, you can do this. I'm doing it in one slide. The write model and the read model could be the events. Obviously, you could have read models that are not just events. Maybe they represent other pieces of data that's not an event, but is the result of. Maybe it's a summary of that data, a collection of that data, whatever. It could be what you need that to be. But your write models and your read models can be working with events, those events being what is stored as an event sourcing pattern. Does that mean everything about your data, everything about your shopping experience, your e-commerce site should be and maybe you got a healthcare application, should every bit of that be in event sourcing? No. Only when you want to track the data and be able to replay the events as the source of truth. When you have that kind of requirement, then event sourcing is the pattern you want to look at. Okay, let's shift gears a little bit more and let's talk about data security. It's not necessarily a pattern, but it's data related, and there's some key pieces that I want you to know about, such as what do they mean by at rest versus in transit? Data stored on disk that's either spinning hard drive or solid state is considered at rest, okay? Data that's in a network, maybe it's coming between Azure storage account and going over to, say, an Azure app service. It's going across the wire, that's in transit. Or going to, like, mentioned here, a microservice or whatever. If it's in the wire, then that's in transit. You can use SSL connections for one way of encrypting that data that's in transit in between the source and the destination. Oh, thanks for coming out, Scott. So key management. So data encrypted at rest uses an encryption key. Makes sense, right? Most cloud providers, Azure, AWS, several others, they will encrypt that data at rest, but you do not have access to that key. Nobody has access to that key. Only their own systems have access to that key. However, you can set up what's called a customer managed key, which is a key encrypting key, a key that is used for encrypting, your data. It adds a layer of security and warm and fuzzy for getting to your data. By the way, I can 100% tell you, for example, Microsoft employees all their support people and stuff, they cannot access your data. Not without like pulling teeth. It is when you have an open support ticket and you're like, oh, we need to look at this data. There is a lot of hoops you have to go through to get them permission to access it on your behalf. So they do not immediately have access to your data. So hopefully you feel good about that. SQL Server offers row-level security. This is really kind of cool. So let's say that you've got the same data, it's the same relative data, and it's stored in the same table, but you've got admins and super users that can see and access that data, but maybe a user can see only their data. Another user can only see their data and not going across, right? Now, so there's row level security that's built in that, and I really do appreciate that as well. One other that I really like is transparent data encryption. This is encrypting data on the column. So you're setting it up so you have encryption, and again, a key for what data, basically specifying the column that is encrypted and which key, which encryption is used for encrypting that data. So you could have things like two different columns that is stored encrypted by using key 1 and an indifferent data. Let's say it's social security number or credit card information that's encrypted by key 2. And you can govern who has access to decrypt, things like that. But it does it at the column level, not just, it's not cell level, but it's at the column level. Compliance. This is a big one. So data residency laws are becoming far more prominent these days, and I'm kind of glad about that, but there's still a lot of hoops that you got to understand, a lot of changes to understand. GDPR, for example, General Data Protection Regulation started over in Europe, England, something like that, in that area. So that's really helping to govern what data is truly being stored and who has access to that data. So you have data residency laws. Where you store your data, where the data originates, matters. For example, if you're in Germany and the data originates, such as PII, that personally identifiable information, let's say that there's a police record, has your name on it, maybe you're just a witness to something, whatever. That information cannot leave Germany. It originates in Germany, cannot leave Germany, because of data residency laws. Why does that matter? And certainly when? Well, if you're setting up data, and depending on what kind of data you're storing, you may have to keep it inside the US, which is also what's called a geopolitical boundary. So if you're doing replication, you have to make sure you understand where you're replicating to see if you're possibly violating any data residency laws. Okay, so we're at the end. Let me know if you have any questions. Right quick, I work for ArchitectNow, Senior Cloud Architect, and we are a basically a custom development shop that does amazing things, that we work in teams. I do a lot of the architecture things for clients, from cloud migrations, we do auditing, all kinds of great stuff. If you have any need for our talents, let me know. And I appreciate the intro, Sam. But here's a little bit more information about me. I do have a book out that I got to co-write with Robert Jerson and Matt Groves on microservices. And so give that a look if you're interested. And Sam, if there's any other questions, let me know.
That was excellent, Sean. I personally have learned a lot and thought it was really useful information.
Good.
I want to give a chance for anyone else to jump in with a question or comment, either verbally or through chat.
Any cons?
Yeah,
any cons to event sourcing other than having more data to store? Not necessarily, because yeah, you're definitely going to have a different storage amount, right? You're constantly storing different records, so the data is going to grow. But like I said earlier, you don't have to store everything as an event source. You can store just pieces of things that you need to, where it makes sense if you have to replay those events. The con is you have to replay those events. If you get into a lot of events where now you've got 1,500 rows, a million rows to replay, then that could be problematic. However, if it's also like a telemetry type data where you don't necessarily care about the beginning value, you might even be able to go back, say, 10 records or 100 records, whatever, and just replay those. And you can use an event ID to archive older data in that case. Yeah, you could, sure. Yeah, you could summarize and archive other data. Generally, for like IoT, maybe you do, maybe you don't. And also for something like that, I know for a company that I've worked with in the past, the telemetry data that they were keeping was not necessarily event sourcing so much as it was just data stored in Azure Table Storage. And they grabbed and replayed from what they needed. They didn't necessarily consider it a replay of events so much as it's just data numbers, unlike a shopping cart, where it's a little bit more bigger of an event. Hopefully that helped. All right, cool. Thoughts on having different schemas for data documents stored in NoSQL? Example, 2 different documents stored in the same container in Cosmos. So I've been doing a lot with Cosmos over the last few weeks and working with a client too, and we really shifted a lot of their thinking, because they're new to Cosmos, on about storing data that's NoSQL in Cosmos. The absolute thing you've got to understand is the partition key. There are some limits that you need to make sure that you can work around, such as a document in Cosmos cannot be larger than 2 megabytes. Okay, well, it sounds like it's actually really hard to do, but it depends on the type of data you're storing. Maybe you need to split your data up so you have some of it's in NoSQL and some of that data is off in a different container or in a different type of data storage, just depending on what you're trying to do. But you can have a container, for example, in Cosmos has unlimited size. Behind the scenes, it takes care of all the physical partitioning. But if you set up your partition key correctly, you can set up and create logical partitions, and which is also unlimited. You can have as many logical partitions as you want. So when you talk about having different schemas for data documents, well, the cool thing is it's actually schemaless, as in there's nothing controlling the schema other than the applications that use that data. So the database itself, Cosmos, doesn't manage it, doesn't care. So that's what they mean by schemaless. So understand your data. If what's the usage pattern? How are you going to use that data? And that's going to help govern a lot of the conversations about building that partition key. Also, Cosmos now has a hierarchical partition key, so you can go up to 3 levels, which is really great to building out the logical partitions. So also, I will put a in the chat here. Go look at some videos by Leonard Lobel or Lenny Lobel. Both he's got stuff in Pluralsight on Cosmos, as well as several things on YouTube that you can catch about how to partition your data. Look at that. That's some very good information there. He's also a Microsoft MVP. That's how I have known him. So, all right, any other questions? Okay, one more. Since you've been working on a lot with Cosmos, any recommendations on the best tool for working with Cosmos? Data Explorer is not ideal for Portal UX. So working with Cosmos, we do a lot of custom development. So we're doing more with using the SDK, .NET SDK for Cosmos specifically. And now the other thing too that I want to mention is that Cosmos is now it's a database platform of multiple database types. NoSQL is just one. You've got Cassandra, you got Gremlin, Mongo, I think is on there. Postgres is now on there. So you can do different things, which is weird. Postgres is a relational database, and yet it's on Cosmos. It's on the Cosmos platform. So it has some of the benefits that the NoSQL has, such as the data replication and cool stuff. But specifically for this, you're looking at the NoSQL part of, or the SQL API part of the Cosmos. So as far as best tool, something I would look at is workbooks, the notebooks, I'm sorry, the Jupyter notebooks. And, but as well, like I said, we do a lot of custom development on that. So doing that, we're able to just kind of play with and see the data that we need to do on that regard.
That's handy to know. Thank you, Sean. Yeah, I mean, coming from a SQL, we use Cosmos and SQL Server a lot, and you get really spoiled with SQL Management Studio, and then you try and go and do ad hoc queries with Storage Explorer, and it just sucks. It's so hard to find the data that you're looking for sometimes.
Look at Azure Data Studio. Azure Data Studio.
Yep.
I believe that will work with Cosmos pretty well.
Yeah. Okay. Thank you.
All right. Any other questions? Anything I can help you with?
I have one more if no one else has a question, or if they're taking the time to type it in. So you talked about replication, you talked about using different databases. What kind of pushback have you encountered from DBAs at different clients?
Yeah, that's the problem, is like when you have multiple databases, you have DBAs are going to push back and go, no, it's because it's just one more I've got to deal with. And I have a talk on microservices, and I think I've given it here sometime back.
Yep.
There's a point where people will start with microservices and then go to the same database. Okay, that's fine for a while. When you get to a spot where the database schema contention is high enough that it's like, no, my application needs to make this change. Yes, but that's negatively affects other applications, other microservices, independent applications. When those contentions are big enough, you're going to have to split that data apart. Now you're duplicating data. Well, do you duplicate it at the database or at the server or at the schema? Because even Oracle's big on schemas, but SQL Server has them as well. DBO, that's just one, right? The default one. So you can split them in various ways. The DBAs obviously are going to push back because there's more work that they have to do. However, if done right, it's just organization that has to be done. And I also believe that if developers are causing the need for duplicate data, that developers can help manage and sync that data, because a DBA is not going to develop a solution for syncing data where you're duplicating it across. That's going to be the developers and architect's responsibility. So there's going to be some pushback, but the pros have to outweigh the cons. And so if there's enough pro, then yeah, you'll convince a DBA. And also when you say, look, we're going to make this change, but here's what we're architecting so that it's minimal effect on a DBA. So try that route.
So in the case where you're talking about having multiple hits against the database and things starting to slow down, if the DBA or the DBA team is not on board with it in the beginning, do you simply move forward with a single database and then just keep monitoring things until you've hit these growing pains and then you bring it to management?
What I would do, my personal recommendation, is you make management aware of it. And so you may say, look, here's our plan. that we understand that this is, we already mentioned this to DBA. He said no, or they said no. But bringing it to you, management, here's what we plan to do. We're going to keep an eye on this. We're going to keep reporting the stats, and we're going to keep showing you how the latency that's building up is causing these adverse effects. Now you're showing that there's enough problems that are now warranting a change for a different solution. And what you're doing in that case is you're just going to keep arming yourself with information until things change. And then that DBA or group will just have to be forced to make the changes. They're there to make things better anyway, right? Just like developers are here to make things better. I'm not saying we're always great at it, but that's why we're here, to build better things for the business.
True. Unfortunately, not everyone sees it that way, and there's always, the last thing I want is another thing on my plate type of attitude. So
true. And then when you go to management and go, here's the numbers. This is what we're facing. We're able to track all of this latency. We're able to track the effects of the latency. Which brings up a point too. Like, why in the shopping cart thing for event sourcing, why would anybody care to track the remove the ad events for a shopping cart? Well, when the end result is they bought products. Well, like for example, Amazon, Walmart, and many other e-commerce sites, they do care about the shopping habits. So that is data for analytics. So they're able to by capturing that information, you're able to capture the shopping habits of people, and that helps for analytics to help understand if they need to change things about the way things flow, etc. Right? So if you're able to show, like, look, here we have a growing amount of latency, and they go, get a bigger server. That's fine up to another point. At some point, it's a change of architecture, not a change of scaling up. So bring the numbers, make the case.
Yeah, absolutely. Also, another point that you mentioned about the shopping trends of users, I think tracking using event sourcing is great, because sometimes consumers will complain, I added this to my shopping cart, how come I didn't receive it, right? And you can go back, if you're doing event sourcing, you can see that at one point they actually deleted it out of their shopping cart.
Yes, you can, or you capture even who deleted it from their shopping cart. What if it was some other process that has occurred that caused a change of that data, and by sticking to the rule, you cannot delete data, deletion is bad, you can only amend, now you have a remove entry. And now you can also capture the who did that. Was it the user? Was it the purchaser, the customer, or was it a process? Which process was that? That kind of thing. Because it also goes back to, what if I need to change where they've added the cart and they try to purchase it, but somebody else actually bought the last one. It was in stock, but now it's not. So now part of what's changing state is a product's availability, and maybe you're adding another record of something occurring about that shopping. Maybe it's not a shopping cart, but a whole order itself that's changing state of what process is causing that change of state, because it doesn't have to be specifically a user or user-initiated event. It could be an automated time process or something to that effect. So,
yeah, very true. All good points.
Cool.
All right. It doesn't look like we have any additional questions in chat, but wanted to throw it out. Any questions or comments, either verbally or chat? And doesn't look like it. So once again, thank you very much, Sean. Highly appreciate it. A very well done presentation and a very informative one. If I may, I'd like to take back the screen just to share some concluding slides.
Sure. And Sam, thanks for having me. I appreciate this. I always enjoy talking to your group.
Likewise, Sean, great having you for a second time, and looking forward to the third time.
Yeah, appreciate it.
The links that I posted in the chat window, you have the link to the YouTube channel. If you would please subscribe to that to get upload notifications when this video is uploaded. Also, tech events are posted on my blog, samnasser.blogspot.com. And again, please subscribe to that to get updates. But more importantly, you have a link for the feedback eval. If you would please take a moment to fill that out so we can provide Sean with some constructive criticism. And for those that joined us after the start of the meeting, we have a special offer from Manning.com for a 35% off a selection of books. The discount code and the link are both posted in the chat window. Also, another thing we like to do is discuss job openings. So TechSystems always has jobs available at techsystems.com/IT-jobs, but always like to ask who's hiring and who's looking for work. So if you would please make yourself known either in chat or verbally. And it doesn't look like we have anything in chat. All right. So moving right along. Should you have a job opening at your place of employment, or if you're looking to jump ship, feel free to reach out to me. My contact information, snasser@nistechnologies.com. You can also find me on Twitter at samnasser. The link to my blog once again. And lastly, if we're not connected on LinkedIn, I invite you to do so. And so with that, thank you all for attending. Thanks to Sean for a great presentation. And I hope you all have a very happy new year and look forward to seeing you at the next meeting. Good night, everyone.